Hello students, welcome to online platform of Abdemi. Today, based on your feedback, again you have selected one problem on hyperbola. So, try to follow what is being said in this problem. Consider the hyperbola x by 10 whole square minus y by 8 whole square equal to 1 with foci at S and S1, where S lies on positive x-axis. So, just let us draw what is being said. So, we have a hyperbola like this. This is x-axis, this is y-axis, and the equation is x by 10 whole square minus y by 8 whole square equal to 1. Focus at S and S1, and S lies on positive x-axis. This is the origin, and therefore this is S. This is one focus, this is another focus, S1. S and S1. Okay. And let P be a point on the hyperbola in the first quadrant. So, this P is one point on the hyperbola. Such that this angle is alpha. Okay. So, let me do it in this manner. They have said that this angle is less than pi by 2. So, just let me draw it once again. So, this is the hyperbola. This is y-axis. This is x-axis, origin, and this is S. This is S1. This point is S1. And P is one point on the hyperbola, and the angle ASPS1 is alpha. This angle is alpha. Okay, and alpha is less than pi by 2. The straight line passing through the point S and having same slope as that of the tangent at P. So, first you draw a tangent at P. Okay, so this is a tangent at P. Now, through S and having same slope as the tangent at P, consider a straight line. The straight line passing through the point S and having the same slope as that of the tangent at P to the hyperbola intersects the line S1P. So, this is line S1P. Okay. So, from S, through S, you draw a line parallel to the tangent, because this line has same slope as that of the tangent. It cuts or intersects the straight line S1P. So, this is line S1P. It cuts this S1P at point P1. At point P1. So, this point is P1. Let delta be the distance of P1, distance of P from the straight line is P1. So, from this point, you drop a perpendicular on this. So, this is one line, this is parallel to that line. So, this distance is delta. This is the perpendicular distance. Okay. And beta is S1P. So S1P length is beta. Okay. So with this description, it is asked that find the greatest integer less than or equal to this quantity, beta delta divided by 9 sine alpha by 2. Find the greatest integer less than or equal to beta delta by 9 sine alpha by 2. That you have to find out. So to solve this problem, this is a very interesting problem. We need to know two basic, very important properties of hyperbola. Once we know these two properties, then it will be very easy to solve this problem. So, as a precursor, as a background knowledge, we will first discuss two important properties of hyperbola, and then we will attempt this problem. So, what is the first problem? What is the first solution? So, before that, whatever you have drawn, you see this diagram once again. So, S1 and S are two foci, and at the point P there is a tangent which is a green line, and through S I have drawn another green line which is parallel to the tangent, having the same slope as that of the tangent, and from P I have drawn, and this line which is parallel to tangent through S cuts the extended S1P at the point P1. Now from point P I have dropped a perpendicular Pn on SP1, and this distance is Pn is equal to delta. Delta is the separation between these two green lines. Okay, and beta is the length S1P. Now we have to compute this expression beta delta by 9 sine alpha by 2, and we have to find out the greatest integer less than or equal to this quantity. Okay, this is the drawing of this problem. We will come back to this problem after learning two basic properties of hyperbola. Let us see what are those. So first we are going to consider a property, that is what, let us see. The tangent at any point of the hyperbola bisects the angle subtended by two foci at that point. So what is that? So this is a hyperbola. Tangent at any point P, which is a green line, it bisects the angle subtended by two foci. So this is a hyperbola whose equation is, say for example, x square by a square minus y square by b square is equal to 1. Now it has two foci, one at S1 whose coordinate is A0, another at S2 whose coordinate is minus A0. So this S1P S2, this is the angle. So the tangent at the point P bisects this angle. So if this angle, if S1 P S2, if it is theta, then angle S2 PT should be equal to angle TPS1. So this is the theorem, this is the property. The tangent at any point of the hyperbola bisects the angle subtended by two foci at that point. Very simple. Now we should prove this theorem, this property. So how to prove that? So what we will do, we will begin with this equation. This is the equation of the hyperbola. Okay? And the coordinate of any point P on this hyperbola, let it be a sec theta b tan theta in parametric form. We can take, because this expression a sec theta b tan theta always automatically satisfies this equation. The equation of tangent to the hyperbola at P can be written from our basic knowledge that you replace x square by x a sec theta and y square by y b tan theta. So I can write x a sec theta by a square. This you all know, and then y b tan theta divided by b square is equal to 1. Okay, so or I can write x sec theta by a minus y tan theta by b is equal to 1. Therefore, I can write or y tan theta by b is equal to x sec theta by a minus 1, and therefore y is how much? B by a x sec theta b by a x sec theta by tan theta. I think it is clear, minus b divided by tan theta. So it is how much? Or I can write y equal to bx by a sec theta by tan theta is actually cosec theta. Sec theta by sin theta cos theta. So sec theta cos theta cancels. So 1 by sin theta becomes cosec theta minus b cot theta. So y equal to bx by a cosec theta minus b cot theta. So what we have written? Y equal to b cosec theta by ax minus b cot theta. That is the equation of the tangent at this point P. Okay. Now the tangent line cuts x-axis at which point? At a cos theta 0. Because if you plug in y equal to 0 over there, that means if I want to find the coordinate of t, I have to plug in y equal to 0 in the equation of tangent. Therefore, I can write bx by a cosec theta is equal to b cot theta. So x is how much? X is a cot theta by sin theta by cosec theta. That means cot theta into sin theta. So it is a cos theta. And therefore, the coordinate of t, coordinate of this point t is actually a cos theta 0. A cos theta 0. So up to this there is no confusion. It is coordinate of a is a cos theta 0. Now, what is happening? See, now equation of S2P. So I have found out the coordinate of t. I have found the equation of line, green line, which is tangent to the hyperbola at the point P. We have started with the point P, arbitrary point P on the hyperbola whose coordinate is a sec theta, b tan theta. There is no harm in choosing such a point in parametric form. Now, what is the equation of S2P? S2P's equation is how much? S2P's equation is, I can write S2P's equation. S2P equation is y minus 0 is equal to gradient of the line, which is b tan theta minus 0 by a sec theta. I am talking about S2P, a sec theta plus a. Okay, multiplied by x plus a. Okay, so this is the equation of S2P. So it is B tan theta by x sec theta plus A multiplied by x plus A. So this is okay. And similarly, this is y minus 0 is y basically, and S1P's equation is again y minus 0, that is y equal to gradient of S1P, which is actually B tan theta by A sec theta minus A. Okay, and S1's coordinate is A0, therefore in the equation it will appear like x minus A. So this is the equation of S1P, and this is the equation of S2P. 3 is the equation of S2P and 4 is the equation of S1P. I think up to this there is no confusion. Okay, now what I will do, I will drop perpendicular from T on these two lines, S1P and S2P. Okay, let us see what happens. So we are going to draw perpendicular from T on S1P and S2P. So this is the D1 is the perpendicular distance, perpendicular drop from T on this line S1P, and D2 is the length of perpendicular drop from T on the line S2P. Now what is D1, D2? Now you know one thing, if there is an equation of straight line AX plus BY plus C equal to 0, and if there is a point alpha beta not on this line, then if I drop a perpendicular from the point P on the line L, then the length of the perpendicular, if I call it D, it is A alpha plus B beta plus C by root over A square plus B square, and this is mod of. So this is a positive quantity which is nothing but mod of A alpha plus B beta plus C divided by A square plus B square. Now here I have two equations, S1P and S2P. These are the equations, and I have a given point A cos theta 0, and D1 is the perpendicular distance of S1P from T. Then what is that perpendicular distance? So it is y equal to B tan theta by A sec theta plus A into x plus A. So it is, if I just use this formula, or if we think that equation of straight line is y equal to mx plus c, then the perpendicular distance from alpha beta on this line is actually m alpha plus c mod divided by 1 plus m square. M alpha, if the point is actually alpha 0, then from the point alpha 0, it is y equal to mx plus c is a given line, and the point is alpha 0, because I am talking about alpha 0 because our point is actually s cos theta 0. This point is lying on x axis, therefore I am considering alpha 0. In that case, the perpendicular distance becomes m mod m alpha plus c divided by 1 plus m square. That you all know. Okay, so using this concept, so here m alpha, so m is actually b tan theta by a sec theta on the line S1P, b tan theta by a sec theta minus a. So b tan theta by a sec theta minus a into a cos theta minus a b e tan theta by a sec theta minus e. I hope it is clear. Just let me write down once again. If you look at the equation properly, then it is not difficult to write the expression for D1. So our S1P's equation is actually y equal to b tan theta by a sec theta minus a into x minus a b e tan theta by a sec theta minus a. Okay, therefore the perpendicular distance drawn from a cos theta 0, which is t, on this line is actually, if I call it d1 is nothing but b tan theta into a cos theta m alpha my plus c is actually minus a b e tan theta by a sec theta minus a mod of this divided by square root of 1 plus m square b square tan square theta divided by a sec theta minus a whole square. So again recall our equation of straight line, if it is y equal to mx plus c and the given point if it is alpha 0, then the perpendicular distance of this point from this line is actually m alpha plus c mod divided by 1 plus m square. That we know. So this thing we have used over here. So d1 is b tan theta into a cos theta by a sec theta minus c, that is a sec theta minus a, minus a b tan theta by a sec theta minus a divided by 1 plus b square tan square theta by a square sec theta minus c whole square. Same thing. Okay. Now if you think about second line, that is, this is d1 I have written. Now if you think about S2P, in S2P actually what happens, the equation is b tan theta by a sec theta plus a. So here it is b tan theta by a sec theta plus a minus, this is I am talking about S2P's case, plus ABE tan theta by a sec theta plus a. Okay, and therefore d2, if I call this d2, that means distance of the point a cos theta 0, if I drop a perpendicular from this point on S2P, the length of perpendicular distance d2 will be what? B tan theta into a cos theta. Okay, b tan theta into a cos theta by a sec theta plus a. Okay, plus a b e tan theta by a sec theta plus a divided by 1 plus b square tan square theta by a sec theta plus a whole square. So it is b tan theta into a cos theta by a sec theta plus e plus a b e tan theta by a sec theta plus e mod divided by 1 plus b square tan square theta by a sec theta plus e whole square. So very simple. So we have considered the perpendicular distances d1 and d2 dropped from t on the lines S1P and S2P respectively. And the expression for d1 and d2 are like this. These are the expressions. Okay. Okay. Now Let us go to the next slide. So this is the expression for d1, that is clear, that we have already explained to you. Okay. Now just let us try to simplify this. So d1 becomes, is what actually, mod, here it is a sec theta minus e, in the top it is ab, tan theta into cos theta is ab sin theta, minus abe tan theta. This is mod, divided by, here it is root over a sec theta minus e whole square, and here it is a square sec theta minus e whole square plus b square tan square theta. So from this we can readily write denominator of the numerator and denominator of the denominator, they are same. So I can simply write it is ab sin theta minus abe tan theta. Try to follow the steps, divided by root over a square sec theta minus e whole square plus b square tan square theta. I can write like this, is it not? Okay. Now talk about the denominator. Denominator is how much? So I have just, it is square root of a sec theta minus e whole square, and here it is mod a sec theta minus e. A sec theta minus e whole square into a square sec theta minus e whole square, and here it is under square root it is there, and here it is a sec theta minus e. So both denominator and denominator of the numerator, they cancel each other. So we are left with this expression. Now denominator is how much? It is, now you all know b square is actually a square e square minus 1. So if I substitute like this, that is sec theta minus e whole square plus a square e square minus 1 tan square theta. So it is a coming out, so it is under square root, it is sec square theta plus e square minus 2e sec theta plus e square tan square theta minus tan square theta. Okay, so sec square theta minus tan square theta is unity. So if I, instead of these two terms, I can write a square root of 1 plus this term and this term is square 1 plus tan square theta, it is e square sec square theta. So I can write e square sec square theta minus 2e sec theta. So it is how much? A 1 minus e sec theta whole square. Okay, and this is denominator is actually, denominator is equal to, in that case, a square root of 1 minus e sec theta whole square. And numerator is how much? Numerator is mod of this thing. So if I take AB out, so it is mod of sin theta 1 minus e sec theta. So I can think it is AB mod sin theta into square root of 1 minus e sec theta whole square. Okay, so this is, so numerator by denominator in that case, which is nothing but d1, is therefore a b mod sin theta into square root of 1 minus e sec theta whole square divided by a root over 1 minus e sec theta whole square. Therefore, d1 becomes, so this term they cancel each other, so I am left with b sin theta. So what we have written, this expression is actually b mod sin theta, d1 equal to b mod sin theta, mod of sin theta. Okay, so this much is clear. Now what about d2? d2 is again similar analysis. If you do, just again once again I will carry out the steps for your convenience. So d2, so here it is a sec theta plus e, so I'll be left with this term. Simple analysis, a b tan theta into cos theta is actually a b sin theta mod a b sin theta plus a b e tan theta divided by same approach, a square sec theta plus e whole square plus b square. B square is again, I will write a square e square minus 1. This, so I can write it is a square e square minus 1 tan square theta. So this term a sec theta plus e, here mod a sec theta plus e, and here root over a square sec theta plus e whole square, they cancel each other, so I am left with this expression. So it is in the numerator, it is a b, you can say mod sin theta multiplied by square root of 1 plus sin theta. If you take out, it is actually e sec theta whole square. I can write like this. And denominator is how much? Is actually, if a square root of sec square theta plus e square plus 2e sec theta plus e square tan square theta minus tan square theta. So sec square theta minus tan square theta is unity. So these two terms contributes unity. So it is a1, and here e square 1 plus tan square theta is actually e square sec square theta. This term and this term. and finally 2e sec theta. So it is how much? A square root of 1 plus e sec theta whole square. All right, so I can write a root over 1 plus e sec theta whole square. So I am left with what? B mod sin theta. So here also d2 is B mod sin theta. So what I have learned? I have learned d1 is equal to d2. This information. So what does it mean? That means from T, if I draw perpendicular on both the tangents S1P and S2P, both the lines S1P and S2P, actually T is a point on the tangent. Through P I have drawn a tangent. At the point P on hyperbola I have drawn a tangent which is PT, cuts the x-axis as T, and this is one S1P one line and S2P is another line. From T I have drawn perpendicular on S1P and S2P, and the perpendicular distances are D1 and D2, and I have found that D1 and D2 are equal. That means this line is the angular bisector of this angle. So line PT is the angular bisector of the angle S2P S1. That means the tangent at any point of the hyperbola, any point is actually A sec theta, B tan theta. Okay, so bisects the angle subtended by two foci at that point. So this is one foci, this is another foci. The angle subtended by two foci at the point P is bisected by the tangent at P. So that we have proved because d1 is equal to d2. Okay, it's because you know in case of angular bisector, if it is an angle, then the angular, if you take any point on the angular bisector, if you drop a perpendicular from this point, any point on this angular bisector, this is angular bisector, then this distance is equal to this distance. So since d1 is equal to d2, here it is d2, not d1. Since d1 is equal to d2 equal to b sin theta, therefore this line, where in this case it is the green line, which is nothing but the tangent, this is the angular bisector of this angle. So this is a very important property we have learned. This will be very handy for solving this problem. Okay, now there is another property of hyperbola, very important property. Let us see what is that. The product of perpendicular distances drawn from two foci of a hyperbola on a tangent is the square of the semi-conjugate axis of the hyperbola. So this is a tangent. If I draw perpendiculars from focus on this tangent, if I call this perpendicular distance P2 and this as P1, okay, so this is one perpendicular and this is another perpendicular drawn on the tangent at P from two foci, then this is an arbitrary point P, then product P2 into P1 is equal to B square. That is also very important property which will be very useful. So how to prove this? So to prove this, let us follow the following steps. The equation is again x square by a square minus y square by b square equal to 1, and arbitrary point on the hyperbola is a sec theta b tan theta. This is arbitrary point. Okay, the equation of the tangent to the hyperbola is already have discussed. It is like this: y equal to b cosec theta by a into x minus b cot theta. Now P1 is the perpendicular distance of the tangent at P from S1, and this is P2 from focus I have dropped a perpendicular, and perpendicular distance is P2. So P1 is what? Again same thing. So just remember, it is y equal to mx plus c is the equation of the straight line, and point is alpha 0. Y coordinate is 0 because I am talking about two foci perpendicular to be dropped from two foci, and both the foci y coordinate is 0. So the perpendicular distance P is actually m alpha plus c mod divided by root over 1 plus m square. Okay, so it is how much? P1 will be, again in this case, P1 is a perpendicular distance dropped from A0 on this straight line is actually what? So it is B cosec theta into A divided by A. B by A cosec theta minus B cot theta by root over 1 plus m square. That means 1 plus b square by a square cosec square theta. As simple as that. Simple application of this. So it is b by a cosec theta into a minus b cot theta divided by b square plus b square by a square cosec square theta plus 1. Okay. And similarly, P2. P2 is what? If I just write down P2 over there. So P2 equation of this straight line is this one. So from minus A0, if I drop the perpendicular, so it is actually B by A cosec theta multiplied by A, negative A, minus B cot theta. So here there will be a mod B cot theta, mod of that divided by 1 plus B by A whole square cosec square theta. Simple. So B by A cosec theta into minus A minus B cot theta by B square by A square cosec square theta plus 1. So these are the perpendicular distances. Their expressions are like this. Simple application of this. Okay. Now let us evaluate P1 and P2. Now see, if I just, my objective is to compute the value of P1 into P2. What happens? Let us see. So P1 is how much? So mod B, A cancel, so B E cosec theta minus B cot theta divided by B square by A square. So what happens? B square is actually A square, E square minus 1. So B square by A square is E square minus 1. So I can write it is under square root E square. So it is okay. Just so not this one. So let us once again calculate the expression for P1 and P2. So P1 is, this is, we will start from this actually. So it is mod B E cosec theta minus B cot theta divided by, So you know b square is equal to a square, e square minus 1. So b square by a square is e square minus 1. So it is under square root e square cosec square theta minus cosec square theta plus 1. Okay. So here it is how much? So b square by a square is e square minus 1 cosec square theta plus 1. So what is that? I know 1 minus cosec square theta is how much? Actually it is sine square theta. It is sine square theta minus 1. I can write like this. So it is actually minus cot square theta. Okay, so I can write from here. If I take this thing out, so it is e cosec theta minus cot theta, and just here it is how much? E square square root of e square cosec square theta minus cot square theta. Okay, so this is the expression for P1. And similarly, what is the expression for P2? P2, in case of P2, I can write, so this is P1. Okay, now P2 is how much? Just let me write over here. P2 is equal to b by a cosec theta minus a. So it is minus b cosec theta minus b cot theta. And here it is how much? Same thing, because b square by a square cosec square theta plus 1, same thing is appearing here. So what is that? So P2 I can write, if I just, since there is a mod sign, so I can write P2 equal to b, you take out mod e cosec theta minus cot plus cot theta, e cosec theta plus cot theta divided by square root of e square cosec square theta minus cot square theta. Okay, I think it is okay. Now if I multiply P1 and P2, then what happens? So P1 multiplied by P2 is how much? So it is e square cosec square theta minus cot square theta mod e square cosec square theta minus cot square theta divided by here square root of e square cosec square theta minus cot square theta whole square, because denominator is same in both the cases. Okay, e square cosec square theta minus cot square theta. Moreover, there is a b square term, because here it is b times this thing, here also it is b times this. So P1 into P2 is b square, e square cosec square theta minus cot square theta mod divided by square root of e square cosec square theta minus cot square theta whole square. So it is nothing but b square, because numerator and denominator are identical. So P1 into P2 is b square. So what we have learnt? We have learnt the product of perpendicular distances drawn from the foci on a tangent is equal to b square. Okay, Now we are equipped with two very important properties of hyperbola. We will see how these properties are useful in solving our problem. So far we have considered only two major properties of hyperbola which you are supposed to know, and we have learned not only the properties, we have learned how to prove that those two properties. Now let us come to the actual problem. So in this problem was given in IIT advanced exam year 2022, if I remember correctly. So here, see, this is the tangent at P. P is a point on the hyperbola. As per given problem we discussed in the beginning itself, P is a point on the hyperbola, and this angle is said to be alpha. Angle SPS1 is said to be alpha. And since the tangent bisects the angle SPS1, so this angle must be alpha by 2 and this angle also must be alpha by 2. The angle S1PM1 is alpha by 2 and angle ASPM1 is also alpha by 2. So this angle is alpha by 2 and this angle is also alpha by 2. This angle is alpha by 2, this angle is also alpha by 2. Now and this distance S1 is given as beta and this is delta. That means from P, if I drop a perpendicular on the line SP1, it is delta. Okay, so this is P1, so this distance is delta. Okay, now this distance is delta. That means delta is the separation between two green lines. This green line is the tangent and this green line is a line drawn parallel to the tangent through the point S. These two are parallel lines. Therefore, because it is said that the slope of this line is equal to that of the tangent. So the straight line passing through S and having same slope as that of the tangent at P. So these two lines have same slope. Therefore, if I drop a perpendicular from S on the tangent, this is also the separation between two green lines. So this distance is nothing but this distance. So this distance is also delta. So MS is, from the diagram, it is very clear that MS is delta. But MS is what? Perpendicular distance of the tangent to the hyperbola drawn at point P. So this is delta and this is S1M, this is M and this is S1M1. So this is SM and this is S1M1. Perpendicular distance of the tangent to the hyperbola drawn at point P. Perpendicular distance from the focus S whose coordinate is AE0. So perpendicular distance of the tangent from the focus S AE0 is MS. Okay, so from focus I have drawn a perpendicular on the tangent, so this distance is delta. And S1M1 is actually perpendicular distance of the tangent at P on hyperbola from focus S1, from focus S1. So S1, M1 and SM are the perpendicular distances drawn from focus S and S1 on the tangent to the hyperbola at the point P. Therefore, I can write SM multiplied by S1 M1 is B square. Is it okay? Because we have learned that the product of the perpendicular distances drawn from focus on a tangent is B square. So what is SM? SM is nothing but Pn. So it is delta. And what is S1 M1? So this angle we have already learned. This is alpha by 2. This angle is alpha by 2. Because alpha is the angle SP S1. So if this is alpha by 2, this angle is also alpha by 2. So I can write S1 M1 is equal to S1 M1 is equal to S1P sin alpha by 2. Okay, because this is a right angle triangle S1 M1P. So S1 M1 divided by S1P is sin alpha by 2. So S1 M1 is S1P sin alpha by 2. So S1P is given as beta. So it is beta sin alpha by 2. So it is delta into beta sin alpha by 2 is equal to B square. But for the hyperbola, what is B square? B square is actually 64. Because this is the given equation, so B square is 64. So I can write delta beta sin alpha by 2 is 64. So my given expression is actually beta delta by 9 sin alpha by 2. So beta delta by 9 sin alpha by 2 is 64 by 9. So 64 by 9 is actually 7 point something. So the greatest integer less than or equal to beta delta by 9 sin alpha by 2 is actually 7. So the answer is 7. So this is 7. So beta delta by 9 sin alpha by 2 is greater than, is actually the greatest integer less than or equal to beta delta by 9 sin alpha by 2 is obviously 7. So this is, so the actual problem takes this much time, very simple. S1 M1 into Sm, this thing is, so Sm into S1 M1 is B square. This is the key point for this problem. And this angle is, total angle is given as alpha. So this angle is alpha by 2. That is another key point. So angle S1P M1 is alpha by 2. That is another key point. And these two come from the two theorems just we discussed before the problem. And just you apply this, we could find the expression like this. So this is all about the problem. It is very interesting problem, beautiful problem, where two fundamental concepts of hyperbola, properties of hyperbola required to be understood properly. Then only within 2 minutes you can solve this problem. Okay. So main thing is that you should know both the properties that we discussed. Okay, I hope it is useful. You go through the problem carefully again, and I think you will be able to solve such applications of the properties where these properties are required to be used. So you should keep in mind these two properties of hyperbola. Thank you very much. I hope it was useful. Okay. Thank you.